Hello, the purpose of this video is for you to be able to compare and contrast what three different types of matter look like on an atomic level. These three different types are covalent molecules, ionic solids, and metallic solids. What do they look like on an atomic level? Well, let's start with covalent. Classic example of covalent is water. Here's water. Now, water and any covalent molecule tends to form molecules. What a molecule is it's got a formula and it has a set number and a set structure. And it's going to be always like this. So if I had some water, I'm going to have a bunch of those molecules. They're separate. They're from each other. They may interact with each other, but they're not together. They're just like, they're not together, but they're together. Now, ionic solids form a checkerboard pattern. Kind of what the checkerboard will do, or will look like rather, is dependent upon the formula of the ionic solid. A classic example, or an easy example, is salt, NaCl. And salt would form something, stay down. Something, it's totally ruined. Kind of like this, where you've got one sodium and then one chlorine. Sodium, chlorine, sodium, chlorine, sodium, chlorine, all the way across. And it's also three-dimensional. So one sodium is surrounded by another chlorine, 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 and a chlorine. So I've got 6 chlorines around me. Now, it's a little different than covalent because you don't really have one piece of NaCl. You have like millions of bazillions of them all together as one big massive thing. And that makes it a little different than a molecule. Metallic is, I've reflectively called it, or not reflectively, says it's kind of like communism. Communism is where everything gets together and contributes to the whole. They contribute delocalized electrons. And these electrons get shared amongst everybody, and it's really forms a really strong bond for them. So that's why metals are really hard to separate, because these delocalized electrons that get shared everywhere form a really strong bond.